Now we're going to wire power. We're going to wire power to the motor, the PWM board. Oh boy! So we're going to put 2 wires in each of these connector and bring them over here to this 5-volt power converter. To do that, we're going to use this red-black pair. You can see it has protruding pins on this end and sockets on this end. So we're going to put the pins into this green connector here. So first, let's loosen these. Don't have to screw them all the way out, just about halfway. And let's see what's plus and minus here. Ground is on the left. So we're going to put the black wire on the left. Got to make sure you get it into the mouth. You got to make sure that it's in all the way too. So sometimes it takes a little pushing. Alright, I think some even those pliers are in order here. Or some tweezers maybe. Okay, let's get our black one in there. Our red one in there. And let's push them all the way in. Come on. Make sure they're all the way in like that. Close the jaws, snap on them tight. Pull test, not coming out. And then of course we have black on ground and red on plus 5 volts. Now you might ask, hey, why do we need 5 volts from here when we have it over here on the Pi? Well, I don't know the exact reason for that, but I can take a guess. This pulse width modulation board is probably going to generate a lot of noise because there are a lot of edges. When you're switching speeds and driving those motors, especially the servos are constantly getting a pulse width modulation signal. Every 20 milliseconds it's getting a couple hundred microsecond edge pulses. That just generates a lot of electrical noise, and if you use the 5-volt source from the Pi, you take the chance of that electrical noise getting back into the computer and kind of messing up its instructions. So looks like they added this converter to isolate the 5 volts from the Pi for maybe that reason. I mean, I can't believe these pulse width signals are taking a lot of energy. That's what this is for the motors. Pulse width signals are just digital low power signals. So I'm guessing it's the edge rate noise.